Okay, I'm on. Welcome back. It's been quite a break we've had here. It's kind of nice this morning. Anyway, let's look at some of the stuff that might be on chapter. Let's kind of review chapter 16 here real quickly. All right. So it deals with the F equals K of X, where the force is equal to stretch a spring. I'm sorry, I'm trying to think ahead here, and the restoring force. But really, what we're kind of interested in for the exam type questions is down here, where we get the potential elastic. It's ready to do work at this juncture. Okay, it's ready to do work, and then when it's ready to do work, it might look something like this. All right, we push it in here, and so what kind of work do we do? So review for the exam. Review for exam 4. That's a terrible pen. That's not going to work. This one might. Oh, this one, I know this one will. This one will work good. All right. So in other words, the restoring force minus kx. But then when we do the calculus on this thing to figure out its elastic potential energy, the elastic potential energy, which is going to look like a lot like, let's do it this way, potential energy elastic. Because electric potential energy, you're going to learn next semester, looks a lot like that, okay? Is equal to 1/2 kx squared. So that's the energy that's ready to do work, all right? So can we then calculate the speed at which, if we've got a, let's say we put something on a spring, smoosh the spring, we got something here inside the barrel of a gun or something like that, and then we shoot it. So the next picture looks like this, boy, whoosh, and this thing goes flying out here. Can we get the velocity, the final velocity, where the initial velocity here is 0? Can we figure that out? Sure we can, because the energy before is equal to the energy after. And so in this case, you'd have 1/2 kx squared is equal to 1/2 mv squared, right? Okay, so that's no big deal. Mv final squared, because the kx goes right here, the elastic, the potential energy elastic is equal to 0, and right here the potential energy elastic is a max, is its maximum. So, and the velocity is 0, so there's no, and that's equal to 0 at that point, the velocity there, right? Okay, and then what would happen if we shot it in the air? Just like, say we had something mounted on a spring, we smoosh it down, we send it up in the air. Okay, and we'll take it from, we want to know how high it's going to go from this unstretched part right here. Well, once again, you've got the energy before, it's equal to the energy after, and if you've calculated this velocity already, then the energy before is going to equal 1/2 mv squared, mv naught squared, because it's got a speed, so it's going to leave here at a speed. So this becomes v naught, which is equal to the v final for this problem, right? And that's going to equal mgh. Okay? Not a big deal. All right, hold on.